PlastiFab.
Welcome to PlastiFab.
We've been here for 37 years or so in this area. Last night's been around longer than that. I've been here for most of that time. We've been building flumes for all of that time. Partial flumes was kind of the main thing, and then polybolus flumes, trapezoidal flumes, H flumes. Who can tell me what this class name is?
This class name?
Yeah, what class is this?
Wet 130. Water and environment.
132. There it is. Collection systems and distribution.
This is collections and distribution.
Yes.
Or is it a series of several classes that you're on? Is it
Yeah.
It's a whole conglomerate.
It's a program.
All right.
We're a cohort.
That's it. A cluster.
Basically, is this more sewage, or is it more wetlands, more?
Waterways.
All of the above. A little of
Yeah.
everything, okay. And we've done, the range of, we've shipped stuff into all of these areas. Our main focus is water and wastewater, mainly for treatment and consumption or disposal.
That's also our focus.
And so you'll be able to see some of the things we do out there, how we build the flumes. Basically, we build fiberglass flumes. Occasionally, we do stainless steel flumes for the applications where people really are looking for something like that. I think the best thing to do is just go out and take a look at a few things, just so you can get some good hands-on. That way, they can be used for calibration. Some areas you might use them just to go out and check, spot checking flow, like irrigation-wise, or maybe some drainage systems.
You guys do all the math for us then, right?
All of the flumes are basically designed to be the same no matter which manufacturer you get them from, and all of the equations, the flow studies have been done years ago on, like Ralph Partial did the Partial flume stuff when he designed that. The Polybolus has a lot of backup information from U.S. Water Lab, did a lot of information on that down in Phoenix. So there's information out there that has the formulas for those. We have a whole set of charts and formulas for all of our flumes that we'll send out as well. So there's flow charts that you can look at the depth and see what the flow rate is, or you can, if you have an instrument, you can program the equation right into it, and it'll give you a flow rate according to what the depth is. There are some things, I can go on and on probably, but a lot of times somebody will say, well, how many throw diameters of straight run do I need upstream of this flume? And there are manufacturers out there that say, oh, you need 20, you need this. We refuse to use that because that's something that was borrowed from closed pipe installations where you have like a mag meter. A mag meter has to be full pipe to be operating properly. And in closed pipe systems, the turbulence due to elbows and corners, T's, valves, or whatever can carry for a long ways in that closed pipe. Open channel flow, a lot of those irregularities in the flow will dissipate quite quickly in the open channel flow. So we'd like to tell people, take a look at where's the water coming from that you're going to measure, and where's it going to. There's three things that you need for a good installation for open channel flow. You need you need low velocity. Basically, you need low velocity so it doesn't just shoot through the flume and not be measured. And you need, I'll call that subcritical velocity. You need nice, fairly smooth, straight flow. Non-turbulent. In other words, the flow needs to be coming towards the flume nice and smooth and straight. You don't want it bouncing back and forth in the channel. And then on the downstream end, you don't want submergence. These are all free flow type flumes. Now, the Partial flume's got a H sub B location where you can monitor that depth. You could go to a whole set of tables and figure out what your flow rate is under partially submerged flow. But anybody's going to be crazy if they try to set it up for that. You always want to try to set your flume up to where you're not going to have submerged flow. You do that just by raising it up. Because whatever flow you have in a stream or channel, before you put the flume in, that's going to be your downstream level regardless, because that flume's affecting what's upstream, that downstream's affected by something downstream, whether it's a pipe size, a slope, or another process with an overflow weir or something like that. So you always, especially if you have existing, you know what your downstream water level is, so you can set your flume accordingly by getting it set to where you don't have that submerged flow. Now, submerged flow doesn't mean it has to be free fall, except for H flumes. But there's a percentage, like in general, the partial flumes, depending on what size it is, it can be from 50% to 70% submerged. That's the downstream level versus the upstream level based off of that inlet flat floor of the flume. Up to that flow generally is still under free flow conditions. So there's a lot of that kind of stuff. There are, and if you look up that stuff on the internet, you'll be able to find several papers on that. You'll be able to look through those, and there's some pretty good evidence.
Over there, they just recently pulled off of the mold. It's got some foam, we put foam ribs on there, and then overlay that foam rib. And what that does is stiffen that sidewall to keep it flat through. Because the fiberglass is somewhat flexible, so we didn't have stiffening, the adhesive stiffening, so when it's set in place, it doesn't go in.
Manhole also? This material that's on the floor, does that get recycled? Like you use it again?
No, you can't use it. This is called it's go through an exothermal process rather than thermal form, it's thermal set. So it actually sets and changes for you can't melt it down there. Building the flume right into the bottom of a manhole. And so we wind our manhole pipe here, and set the flume up on the table, get it all level, and then we'll laminate this fiberglass manhole right around the flume. There's one there that's pretty much finished, has a hinge cover on it. And that way, like industry uses them a lot. If they need to monitor their flow, they already have their sewer system in. They can dig down, take this thing right in the line, hook the pipes up, and start the flow and be reading their effluent. So now they pay the sewer bill based on their sewer rather than the water bill, especially if you use a lot of water.
See the flume built in here. All constructed, drop it in. Get the flume and the flow rates not based on the water level.
We came up coined the
false
term
bottom.
magic bottom because it does a lot of magic things. If somebody's got a partial flume in and they found out that it started to, and it actually started sagging or it isn't level anymore, we can supply a magic bottom and we can allow for that leveling, so they'll drop it into place. It gives them a new flat, perfectly level floor. So now the flume has a new zero level, but it's a flat floor, so they know they're getting good readings. More often than not, it's
just a retrofit for the existing floor.
Yeah, more often
Magic
than
bottoms
not,
are retrofit
it's
for
a
the
submergence
existing.
issue. They've got something going on downstream that's giving them so much backwater that in a lot of cases their flume's submerged and they can't get good readings. So what we'll do is we'll drop in a magic bottom. Now they have a new zero level, which is high enough to keep them out of that submerged flow, because the downstream water is going to stay where it is. We just change the upstream water depth, and now they can get a good free flow reading out of that partial flume. I think Mike mentioned that they're full of concrete, and that makes it easy because of the shape of that magic bottom. It's not going anywhere. If we make them heavy enough, they just drop them in, it sinks right to the bottom, and they're ready to go. If they can dry it out, they can go ahead and put some sealer around there, but really, you're not going to have much flow going around the outside edges. it'll actually slide downstream a little bit to where it'll seat against the sidewalls of that flume. The only thing is, when they do that, they got to make sure that they either buy a new gauge or know that that gauge that's in the existing flume isn't zeroed anymore. Help them decide which flume will work best for the installation. We start by asking a lot of questions. What your flow rate's going to be, minimum, maximum. What are you using it for? What's most important, the lower flows or the higher flows? So there's a lot of questions. You know, where's it coming from? Where's it going to? You need to know where it's going in order to pick the best.
Is everything custom or do you have a catalog?
There's a basic catalog of different size and types of flume, but then we customize each one to kind of fit together.
Might expect to see the
That's it? Probably more. But that's
Yeah, if you want to look something down, probably.
50-year lifespan for a flume.
Any open channel flow measuring flume, what happens is, what's supposed to happen is the throat section of the flume backs that water up, and as the water passes through the throat, it goes through critical velocity. There's a formula for critical velocity. Critical velocity is the square root of GD. G being gravity at 32.2, D being the depth of water in feet. So, as the water passes through the throat, it goes through critical velocity. It's recommended that upstream of the flume, your velocity is half of critical velocity. Generally, if it's half, that means the water's slow enough that it's going to be nice, smooth filaments coming towards the flume. It shouldn't be too turbulent at that point, and it should come through. So, a lot of times in a flume, if you have a wider area upstream or a deeper area, you can get that velocity down pretty easily. A lot of times, if you're coming from a small pipe, or if you're coming down a big slope, if you got a lot of velocity in that pipe, it's going to want to shoot right through that flume. That's one reason I never say so many pipe diameters upstream. If you got a lot of slope, so many pipe diameters isn't going to do anything for you. It's where's that water coming from? What's the velocity? What's causing that flow? So that's something to really keep in mind. The upstream velocity, turbulence, and then whatever your submergence is downstream. You take care of those things and you'll have a good installation. We do have some things we can do if there's an installation that has too much velocity. And it's just, a lot of times, man, my meter says I'm getting less flow and I actually get more. Yeah, that's because the velocity is shooting through it. It just sucks right down through the flume. We have what we call energy absorbers and tranquilizing racks. So we put a target plate in there and then some specialized racks to spread that flow out, slow it down. We actually have a test piece out here. We show our representatives when they come to town. We hook a fire hose up, and in this much space, we got the water calmed down to where they could actually monitor it in the flow. Shooting out of a fire hose. So there's some things you can do with it. Trapezoidal flumes used for?
Trapezoidal flumes, what do they use for?
There's a couple of reasons. Originally, and I mentioned to some people, a lot of the trapezoidal flumes, like the 2-inch 45-degree trapezoidal flume, is made to fit concrete ditches, the slip forms they use for concrete ditches for irrigation. That's kind of where the size and shape of that thing came from. It'll actually fit right in that ditch and work real nicely for measure water for irrigation purposes. We use a lot of trapezoidal flumes around the country in wastewater applications, actually, especially industry where they got fairly low flow and they want to get good resolution. And the 60-degree V trapezoidal flumes are used for that. The 60-degree V is a real small throat, so you get good resolution at the low end. So they can actually, if you're monitoring, you can imagine the smallest Palmer bolus flume we have, if they had a 4-inch pipe coming through and you matched up that flume for that size, the throat width on a 4-inch Palmer bolus flume is 2 inches wide. But you can imagine 2 inches wide with a real small flow, that's not going to be much water depth. It's going to be real difficult to see the differences in changes, where with that 60-degree V, you get a really good resolution. A lot of times people will say, what's the accuracy of this flume versus that flume? Really, all the flumes, because of the open flow, the way it works, it's real basic physics. They're all pretty much the same accuracy. The real issue is resolution. A given change in head for a given flow length. So if you can get the resolution where you need it in the area that you're most interested in, that's the flume you want to pick. H flumes are one that probably have the most broadest flow range, like 100-to-1 flow range. The H flumes, you can get the real low flows, but you really have a lot of capacity on the high end. H flumes generally were used for irrigation purposes, runoff studies at the end of fields and things like that, so you can see how much water was actually used. Or they use a lot for rainwater studies. If you have a plot, you want to see how much rainwater is leaving that plot. The H flumes got that flow range to collect the water for the real small flows and be able to monitor it, as well as the real high flows still have the capacity for it. So that's where you see H flumes more often than not. We sold quite a few of them down to California along some of their highway projects. They'll collect all their flow so they can collect and monitor, and actually, I think they're actually sampling as well the effluent or all of the flow that runs off of their roadways.
So, trapezoidal here.
I'll have to cut a hole in this one. Otherwise, you got a nice, weird looking bathtub.
We put spreader angles because the fiberglass tends to want to shrink in around corners, so we'll spread and make sure this stays at the angle, so they got a gauge so they can set it for when they clamp these in and go to spread. There'll be pipe stubs put on the end for the water to go in and out of this. This is what we call a large 60-degree V trapezoidal flume.
60-degree V trapezoidal.
Basically, the throat in this flume, it goes through a V shape, so you can get really good resolution for the real low flows. Like an inch deep in here is about 1 gallon per minute.
An inch deep.
Of course, we got the gauge. Now, most of our gauges are in feet and centimeters, so depending on where they go, we did that for our Canada friends, since we ship a lot of them to. There's charts, and it's pretty popular for, you can measure submerged flow if you measure the head at the upstream and you measure it at the downstream level at the H sub B. All of the studies that were done with stilling wells, and the port on that partial flume is way down, fairly low at the bottom of that throat at the outlet edge. A lot of people want to try to put an ultrasonic over there. I don't know how they can ever get it to work because your water's either sloping down or it's got a lot of back turbulence coming in. Generally, you can tell just by looking at a partial flume if you're approaching submerged flow. If the flow is going through that throat and it hits the downstream water and that turbulence or hydraulic jump is outside of the throat, you've got free flow there. You don't have to worry about that. Sometimes that turbulence gets into the throat a little bit, then you're getting into that transition area where you really want to measure, but it's hard to measure. I would suggest to anybody, if you want to measure H sub B, use a stilling well at that location. If you put a bubble pipe in there, it's that high velocity water going through, they're going to aspirate and change the level that it should be reading or not. We don't know. But if you put it in a stilling well, you've got what matches their original charts, their original flow studies were done with stilling wells. So something to keep in mind in the future if you see something like that.
Partial flume here.
So this partial flume's got an inlet adapter, it's got an outlet adapter. Again, there will be pipe stubs installed on each end of this for the water to flow through. It's got a gauge on that side that you can't see from over there. We have a sample pipe in a cavity right here. This it's down at the end of the throat basically, because everything's stirred up pretty good right there, so you aren't picking up solids that might have settled like up in the upstream end where you've got lower velocity.
Having the tube at this end, this is the outlet, so the turbulence created by the tube at this end doesn't make a difference.
And it doesn't matter. It is in the cavity, so it's flush as well, so rags and things don't hang up on it. But the reason for this end mostly is the turbulence. So if there's any solids and turbidity to that water, it's going to be pretty well mixed by the time it gets in there, and you're getting a good representative sample.
What factors determine whether you want it made out of fiberglass or stainless steel?
It's almost always fiberglass.
Okay.
Stainless is a special request. If you have some
Toxic solvents or
ketones and things that are going to eat into the fiberglass, it's usually, fiberglass is real good for acids, but the bases are pretty tough on it. We also built a whole line of control your water level, or you may want to have a temporary shut-off in front of a piece of equipment that you may need to maintain. They drop the stop logs in there so they work on their equipment, then they can pull it back out again. Rather than have a gate in there that's always in there with the head rails and all that stuff sticking out. So stop logs, we sell a lot of stop logs.
You guys built the whole metal.
Pardon? And we'll have metal guide frames that those will slide into, or fiberglass. These particular shelters are going to have a door on each end, so we're still working for the, there's a section that goes in there that will have the door,
Hurricane Katrina.
the 3-point latch. We put some electrical in there, fans and heaters and that kind of stuff. But basically, it's a fiberglass shelter. We build the parts on the rib wall mold and we assemble them all. And we laminate them all together on the inside, so it's a completely sealed up one-piece unit.
Who orders these?
These particular ones are going to a sewage treatment plant for a motor control center, actually, goes in them. But they go into areas where there's corrosion problems, you know, a lot of chemicals. A lot of times you have chemicals, chemical pumps, some of the chlorine applications and whatnot. So you need them for corrosion resistance.
erosion resistance.
And they're a turnkey deal. You pour your slab, drop the structure on, and it's already, you know,
ready to go.
You just
Manhole there, vent cover here, manhole. All our ballast was
Situations where you
existing
don't
manholes
have
work well.
a lot of room to put in big end adapters and partial flumes, like that small one we saw down there, that 6-inch throat. It was a pretty big flume. Well, another thing to keep in mind, if you see somebody that says, I've got a 10-inch, or I've got a 12-inch pipe, so I'm going to put in a 12-inch partial flume, right? No. Because the flume needs to restrict that flow. You can't have a flume with the same throat width as a pipe, or the water's just going to flow through there, not even know it's going through a flume. Generally, you're going to have a flume with a throat that's a lot less that will back the water upstream. I suppose we could talk about magic bottoms a little bit. Everybody saw the magic bottoms.